Now we'll discuss the difference between the thermodynamics and the mechanics. So we are discussing the mechanics and the thermodynamics, and I am taking an example of a bullet fired, and there is a wooden board which is the target. So the bullet has to be fired on this target, and what happens is when the bullet is fired, so it has some velocity v with which it gets fired, and it get embed into the board. So due to that embedment into the board, there is an increase in the temperature of the bullet. That increase in the temperature of bullet is due to the thermodynamics, while whatever we are looking at here, that is the velocity of the bullet and how the collision is happening with the board, all this comes under the mechanics. Okay. So I wanted you to understand the difference between the mechanics and the thermodynamics. So when bullet goes into this board, there is a increase in the temperature of this bullet. Why? Because of the internal there is so the work that is done due to the change in kinetic energy of the bullet when it gets embedded is going to convert into the increase in the temperature of the bullet due to the increase in the internal energy of the bullet. So I will come along, I will tell you the concept of internal energy in the next few lectures. We will be going to discuss it in more detail, but this is the main difference between the mechanics and the thermodynamics. So for your understanding, I can write the distinction between the mechanics and the thermodynamics. So in mechanics, our interest is in the motion of the particles or the body under the action of force or force and torque. Is not concerned with the motion of the system as a whole. In fact, it is concerned with the internal macroscopic state of the body. So in above example as we discussed, so when a bullet is fired from a gun, so what happens? Its kinetic energy in particular, not its temperature, gets changed. When the bullet pierced the board when the bullet pierced the board and stops, the kinetic energy is converted into heat. Which then changes the temperature of the bullet and the board. So, somehow we can conclude that temperature is related to the energy of the internal motion of the bullet, not to the motion of the bullet as a whole. So, what we have discussed here is like we are not interested in thermodynamics that with what velocity the bullet is moving. We are not interested what is the kinetic energy of the bullet in thermodynamics. What we are interested is what is the change in kinetic energy that is converted into the heat, and that heat is actually changing the temperature of the bullet with the board when it get pierced into the board. So, this is the main difference between the mechanics and the thermodynamics. We study we wanted to know the motion of the body as a whole. So, if you are pushing some body, if you are pushing this body, so then there is a motion of this body, and so if there is a motion of this body, then it is called a mechanics. But if it is something like if I fall it down, the falling comes under the mechanics, but while falling there is some disorder, there is an increase in the disorder in the internal structure of this body, that so we have to study that change in the disorder in the structure of this internal structure of this body in the field of thermodynamics. So, this is the main difference between the mechanics and the thermodynamics. Now, as we move along, as I discussed that we need to in this chapter we wanted to learn what are the rules that are governing this conversion of energy from one state to another. So, there are some rule as a whole that are there. And what we called as there are laws, that is zeroth law of thermodynamics, then we have first law of thermodynamics, then we have second law of thermodynamics, all of these laws are having some these are very important laws, because when you will see when we are going to take these laws one by one, you will see the importance of these laws. If maybe you will see that the first law is valid, if second law is not valid, you will see you cannot see those system in physical where only the first law of thermodynamics is valid and the second law of thermodynamics is not valid. So thermodynamics tells us that there are some rules to follow, and these rules will tell us how the one form of energy is converted into the another form of energy. So first, before going to this law, so we need to understand the what is zeroth law of thermodynamics, and in order to discuss the zeroth law of thermodynamics, we need to understand what is the thermal equilibrium. So now we will be going to start thermal equilibrium. So what is thermal equilibrium? In mechanics, if we see what is equilibrium in mechanics, so in mechanics equilibrium is nothing but the net. Equilibrium tells us that the net external force and the torque on the body is 0, then it is in mechanical equilibrium. But in case of thermodynamics, it appears in a different way. In context of thermodynamics, equilibrium refer in a different way. So here we say that the state of the system is an equilibrium state if the macroscopic variable that characterize the system should not change with time. So the macroscopic variables, we need to know what are the macroscopic variables, what are the most important macroscopic variables. So macroscopic variables defining the equilibrium are density, viscosity, moles, that will take care of the mass, moles or mass, whatever it is. Then we have pressure, volume, composition. Composition we can say that comes in terms of moles only. So these are the macroscopic variables that are important to discuss when we are studying the thermodynamic equilibrium. In general, whether a system is in a state of equilibrium or not, that depends upon the nature of the surroundings and the nature of the wall that separate the system from surrounding. So, if we are having this kind of system, so if we have this kind of system, let us say some molecules are here, and let us say this is the wall. If I say this wall is adiabatic, if this wall is adiabatic in nature, then no energy, no transfer of energy is allowed in between system and surrounding. But if it is diathermal, let us say if it is, this wall is diathermal, then there is a energy exchange. So, with this I end up this class here, and then we will discuss in the next, we will continue the thermodynamic equilibrium with these concepts in the next class. Okay, thank you.